Ever wondered how AI could truly understand both what you see and hear? Like not just detecting a dog barking, but figuring out why it's barking or what it's trying to say. That's the big challenge in a field called Referring Audio-Visual Segmentation. And today, we're diving into a groundbreaking new dataset that's pushing AI to think way deeper. Let's start with the basics. Referring Audio-Visual Segmentation, or RAVS, is all about helping AI identify specific objects in a video based on descriptions that mix text, sound, and visuals. For example, if someone says, "Point to the dog that's mimicking the cat's meow," the AI needs to connect the sound of the cat's meow with the visual of the dog. But here's the problem. Most existing datasets only look at surface-level clues. They might recognize a loud noise or a specific sound pattern, but they can't understand the meaning behind it. Take the classic example. Who's making the loudest sound? Traditional systems would just detect the loudest audio, but they'd miss the bigger picture. What if that loud sound is a cough? Or a scream? The real-world context matters. That's where OmniA comes in. It's a new dataset designed to force AI to reason about audio-visual clues, not just react to them. So what makes OmniA different? Let's break it down. First, it supports 8 types of multimodal expressions. Think text with sound, text with images, even speech instead of text. Imagine asking, which instrument is the leader in this band? And the AI has to analyze both the visual of a guitarist and the sound of a melody. Second, it focuses on understanding audio content, not just detecting it. Instead of what's making noise, it asks, who's most likely to be sick based on coughing sounds. Third, it requires complex reasoning, like linking a sound to a concept, e.g., coughing right arrow illness, and explaining why the AI made a decision. To tackle this, the researchers created OISA, a model powered by a Multimodal Large Language Model, MLLM. OISA doesn't just segment objects, it reasons through clues. For instance, if the input is, the person who spoke Korean is the leader, OISA connects the sound of Korean speech with visual cues to identify the right person. And unlike older methods that process videos frame by frame, OISA uses a smarter approach to track objects over time, like following a guitar's sound as it moves across the screen. The results? OISA outperforms existing models on OmniA and even generalizes to tasks beyond its training data. This isn't just a technical win. It's a step toward AI that can comprehend the world as humans do, connecting sensory inputs with contextual understanding. But this is part of a bigger trend. Researchers are now teaching AI to spot patterns that blend sound and sight, like how a dog's bark sounds different from a car horn or how a meow matches a cat's movements. Studies like prompting segmentation with sounds show that adding audio clues helps models generalize better, moving beyond memorizing images to understanding context. It's like teaching a child to recognize a dog not just by its shape, but by its bark. Meanwhile, large language models are revolutionizing how AI interprets videos. Systems like VISA and LAVT use text prompts, find the red ball, or track the person walking to guide object detection in real time. This is a leap from old methods that just labeled pixels. Now, AI follows instructions, making it far more flexible. But here's the real game changer: multimodal benchmarks. Papers like MMTbench and a VQA create super challenging tests where AI has to juggle multiple modalities. These benchmarks push models to solve problems that require both visual and auditory reasoning, like identifying a sizzling pan by its sound and the steam rising from it. The implications are huge. Imagine a robot in a kitchen using both the sound of a bubbling pot and the visual of steam to know when to flip a pancake. Or an app that helps the visually impaired by describing not just what they're seeing, but what they're hearing. This isn't just about smarter tech. It's about machines that can comprehend the world as we do, stitching together sensory clues into a coherent story. So what's next? As datasets like OmniA grow more sophisticated and models like OISA become more nuanced, we're not just building better AI. We're building AI that thinks, reasons, and connects. And that's where the real innovation lies.